Okay, so here's your homework. More problems from 7.1 to practice. Page 452, problems 20 through 36 by fours. And problems 44 and 47. And then you are to read section 7.2. And there are formulas in gray boxes that you need to write down. Write down the formulas in your notes in gray boxes. Okay, the other thing, so there's a gray box on page 457 that says the disk method. All right, and it gives you formulas. There's a gray box, it's kind of gray-blue on 459 that gives you the formula for the washer method. There's another formula on page 461. All right, so, yep, good for me. So those are the problems that you should do, and read 7.2 between now and when? Next Monday. Yeah. That's a really long time. So Sunday night 11 o'clock is when you'll start? Bad idea. All right. So next, we're going to take a look at a problem. We're going to find the area. It's not about what you want all the time. All right, so we're going to determine the area of the region enclosed by y equals the sine of x, y equals the cosine of x equals pi over 2. Oh, nope, never mind. I don't want to do the pi over 2 thing. I just want to do sine of x and cosine of x. Find the area enclosed by y equals the sine of x and the cosine of x. So what is the first thing we do? Find area between. And I'll add a little something to that after we look at the graph. But what do? We need to graph it. Do you know what the graphs of sine and cosine look like? Yes, you do. They're curves. So I'm going to draw one full period on each side of the y-axis. So this is, each of these marks is a multiple of, let's see, this is 2 pi. The period length of sine and cosine is 2 pi, so that's pi. That's pi over 2, and that's 3 pi over 2. And this is negative 2 pi, and this is negative 3 pi over 2. And this is negative pi and negative pi over 2, and this is 0. And the highest that the sine function and cosine function goes is 1, and the lowest is negative 1. So the sine curve, I'm going to do the sine curve in purple. And the sine curve, who remembers where the sine starts? Starts at the origin, 0, 0. At pi over 2, the sine of pi over 2 is 1. Back down to 0. The sine of 3 pi over 2 is negative 1. The sine of 2 pi is 0. Okay, on the other side, it does, it back up. It's basically the same exact picture over and over again. And this would go up and down, up and down, up and down constantly. All right, so now the cosine graph I'm going to do in green. The cosine graph is in green. And where does the cosine? Cosine is 0. 1, and then the cosine of pi over 2, 0, negative 1, 0, 1. Here's what the cosine looks like. And then it goes, isn't that a pretty graph? So we're trying to find the area between those curves. So the question is, which area? Okay, because don't we have Don't we have this area right here? Isn't that an area? Isn't that an area between the two curves? Okay, is this the same shape? Okay, what's happened to it? It's reflected over what line? Pi over 4. This shape is the same as this shape. They're just reflections of each other. Is this the same shape? Yes, it is. Okay, so what if I ask you to find the area of one section? Find the area of one of the sections that are bounded, and then you could multiply by infinity. How many of these sections are there going to be on the entirety of the graphs, sine and cosine? Don't these just keep going? 7? Just 7 of them? Okay, right now there's 3. 7 total? No. Okay. So all we're going to do is find the area of one of these. All right, so let's pick one that's nice. I don't know that there is one. So do you want to find the area of this one?
Yeah.
Or this one?
Yeah.
Or this one?
Yeah.
Does it really matter which one?
Yeah.
It really doesn't. They're all going to be the same. We just need to be able to write the integral. So let's see. Let's pick this one. Okay, so we're going to find the area of this one. So we need to figure out, where does this start on the x-axis and where does it end? What would be our limits of integration? Our limits of integration are always x values where the area starts and ends. That's so important that you understand that. The limits of integration are x values. So where do you guess this is? It's pi over 4. What if you didn't know that? How could you figure that out? What happens to the sine and the cosine graph right there? They meet. They're the same. They're equal, right? So you could answer the question, where is the sine of x equal to the cosine of x? Which really isn't something you can solve. It's just something you can look around your unit circle. Remember, in your unit circle, all the ordered pairs tell you the sine and cosine? So which ordered pair has the same x and y value? Isn't it pi over 4? Radical 2 over 2 and radical 2 over 2? Okay. So pi over 4, and then what would this one be? Where are they the same again? 5 pi over 4? You know, over in the second quadrant, 45 degrees in the second quadrant? Or isn't it negative pi? Well, no, they're not the same there, because the one's negative and one's positive, but aren't they the same way down? How many of you don't even have a unit circle yet? Do you know that you can just go online and type in unit circle and there'll be about 5 million images pop up and you can print it out? And if you have to fill it in, guess what? You should be able to. Do not go ask Mrs. Price for a unit circle. It is not her job to give you one. She gave you one last year, or 2 years ago, or 13 years ago. I don't know. Okay, so here's your unit circle. Here's pi over 4. Here's where the sine and cosine are the same, because the ordered pair is radical 2 over 2, comma radical 2 over 2. Where else are they going to be the same? Right down here. Is that 5 pi over 4? Okay, yeah, it is. Okay, 5 pi over 4. Okay, so what's the top function here? Sine of x minus the cosine of x. All right, we're going to finish this whole thing. Chase, be quiet, please. All right, so antiderivative of sine of x. Negative cosine of x. Antiderivative of cosine of x. Sine of x, but notice it's negative, so I just leave the negative. I need to evaluate that from pi over 4 to 5 pi over 4. Which limit of integration do I plug in first? The upper limit, 5 pi over 4, so negative cosine 5 pi over 4 minus sine of 5 pi over 4 minus negative cosine of pi over 4 minus sine of pi over 4. We should already know what's the cosine of 5 pi over 4. It's radical 2 over 2. Negative radical 2 over 2, which makes that negative and that negative make it positive. The sine of 5 pi over 4 is another negative radical 2 over 2. So that makes it plus. So how many radical 2 over 2's do I have?
2. So
2 of them. So 2 radical 2 over 2's is just radical 2. I'm going to add the opposite of each of these. The cosine of pi over 4. Radical 2 over 2 plus another radical 2 over 2 gives me again 2 radical 2 over 2's, which is another radical 2. My final answer is 2 radical 2. Decimals are not acceptable when you look values up on the unit circle. All right, that'll be the last one I do.